right, so good morning or good afternoon, depending on where you're joining us from, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. If you're joining us for the first time, we're all about bringing conservation, adventure, and science into classrooms around the world, and this month is one of our biggest ever. I think by the end of the month, it's going to be 65 programs in 22 days, which is absolute insanity, so thank you so much to all the classes for joining live and on YouTube as we continue to highlight amazing speakers and stories from around the globe. Now, October is always our month dedicated to space. We've had astronauts, satellite engineers, we've had rocket scientists galore. It's been a really, really fun time. But today we're going to do something a little bit different in the realm of space, and that is go searching for exoplanets. So we know our own solar system. We know we live on the Earth, hopefully. There is a bunch of other planets that are around us that orbit our sun. But now scientists are looking into the farthest reaches of the cosmos for other planets orbiting other stars. What other worlds could be out there? So we're joined live by Frédérique Baron. She's an astrophysicist, and she is the Scientific and Education Public Outreach Coordinator at the Institute for Research on Exoplanets at the University of Montreal. She's joined us many times before in both official languages in Canada, French and English, and it's such a pleasure having her on. So without further ado, Frédérique, take us away, and we look very forward to exploring the cosmos with you. Go for it.
Thanks, Jesse. I'm very happy to be here with you, with all of you from all over America today to talk about, well, exoplanets and astronomy in general. So I'm an astrophysicist. What does that mean? Astrophysicist, sometimes we also say astronomer. But it's not the same as astrologer, like astronomer. I study the stars or the planet. In my case, especially, I study exoplanets. But when you are an astronomer, you get to do a lot of things. So I do a lot of outreach events, which means that I get to talk to kids, to adults, to everybody about the universe and how wonderful it is. I also get to go to telescopes, like big telescopes, like this one that you see here. This one here, this is the Gemini telescope in Hawaii. And here I'm on the catwalk of the CFHT telescope, also in Hawaii. It's one of the best spots in the whole world to look at the stars, because you are on top of a big mountain, so you're really high up, higher than the clouds, and it's really, really dry. So it's really one of the most wonderful spots to look at the universe. So I got to, during my studies and in my research, I get a lot of data from those big telescopes. And a small telescope that is really near and dear to my heart is this small one here, which is a 1.6 meter, so it's not so big. It means that the mirror is about the same size as me. I'm not so big also. And this is a telescope that is in Quebec. It's about a 3-hour drive from where I work at the University of Montreal. And it's a really nice observatory where students, starting from their undergrad, so when they get into university, they get to use this telescope to do science. So it's a really nice telescope. So when you are an astrophysicist, like I am, you get to do a lot of different things, from going to the telescope, looking at the universe, to talking about the universe. Okay. So I study exoplanets. So an exoplanet is like a planet, but it orbits a star that is outside our solar system. And I work at the Institute for Research on Exoplanets. So we are about 50 researchers, and our goal is to explore new worlds because we are searching for life. When we think about life on an other world, on an exoplanet, I mean, we get to think about aliens. So aliens feels like science fiction, right? But here, it's not just science fiction, it's actual science looking for life. Maybe not like little green like monsters, but still life like bacterium that could be on another world. That's super interesting. And this is the kind of science that we do at the Institute for Research on Exoplanets. Okay, let's take a step back. So this is our star. This is the sun. Well, this is the sun when we look at it through a telescope. You should never look at the sun with your own eyes, That's a really bad idea. Because when you look at the sun with your own eyes, you can burn them. So never do that. But with a special telescope, we can look at the sun and we can see like a picture of our star, the sun. And around the sun, we have a lot of planets. I guess you should be able to tell me how many. So I know I cannot see you, but just think in your head, like how many planets are there in the solar system? It's hard, right? We'll count them together. So this is the first one. It's really gray. You see like lots of craters a bit everywhere. This is Mercury. And then this is the second one. It's the second one, and that's a bit strange, is the hottest planet in the solar system. Well, you could think that Mercury is the closest one to the sun. You could think that Mercury is the hottest one because the sun is really, really hot. So the closer you are to something that's really hot, it should be warmer. But Mercury has no atmosphere. So during the day, when Mercury is facing the sun, it's going to be really, really warm. But during the night, on a night on Mercury, it's going to be super cold. On Venus, it's about always the same temperature because Venus has a really thick atmosphere, which means that it's about always 400 Celsius on Venus. And now I'm realizing that maybe I should know that in Fahrenheit, but I have no idea because I'm always working in the metric system. But it's still really, really warm. Let me see. Like when I bake cookies at 400 Fahrenheit. 400 Fahrenheit, it's 200 Celsius. So it's even at that temperature, it's much cooler, much cooler than Venus. So Venus is really, really warm, and it's really warm night and day. It's a really intriguing planet. And this one you should know it. This is the third planet from the sun, and it's the planet that we live on. This is Earth. Our planet. Earth is really special because it's the home of all humans. But it's also the only place in the whole solar system, in the whole galaxy, in the whole universe that we know for sure that there is life. That's on Earth. We're looking for life elsewhere in our solar system or on those exoplanets. But we only know that life exists on our planet, on the Earth. So it's a really special planet. This is a planet that I think you should know too. It's called, sometimes we call it the red planet because it's red, right? It's so red. Is it? Is that red? I would say it's like, it's not quite red, right, Jesse?
A little bit orangey. The orange planet, we'll call it.
Yeah, it's more like an orange planet. It's because on the surface of Mars, it has a lot of iron. Iron that has rusted. So it's the color of rust. So it's not quite red, but when you look at the planet with the naked eye on the Earth, and this is something that you can do even tonight, you can see Mars with just your eyes, you will see something that is white-ish red, like with a tinge of red. And this is why it's called the red planet. But it's not so red. Okay, so we have now 4 small planets: Mercury, Venus, the Earth, and Mars. They're small, they're rocky. They are the 4 planets in the solar system. And then the next planet, the 5th one, is so big. It's really big. It's the biggest planet of all the planets in the solar system. It's also my favorite. It's Jupiter. Jupiter is really big, and can you see here? You see that big red storm? In this storm, you can actually fit 2 or 3 times the Earth. That planet, Jupiter, is really, really big. I really like the planet Jupiter because when I study exoplanets, I study exoplanets that looks like Jupiter. So they are about the same size as Jupiter, but they are orbiting, they are going around another star than our own sun. So this is why I like Jupiter, because it's closer to us and it's really pretty and really big. But maybe this is your favorite planet. I know that for a lot of people, Saturn is their favorite planet because of the big rings. You see the big rings around Saturn? They're really, really big, but really, really tiny, like on the side. And I think this is why people love Saturn so much. But Jupiter also has rings. They're just much smaller. Saturn is also a big gas giant planet, like a giant, really a giant planet. but it's a bit smaller than Jupiter. But it's really funny because if you could put Saturn in a bath, Saturn would float. It's really not dense. It's really it's less dense than water. And then we have the 7th planet. This is Uranus. It's blue, slightly blue, because of the gas it has in the atmosphere of that planet. And the next and the last one, this is the 8th planet in the solar system. This is Pluto. Oh, no, sorry, this is Neptune. Neptune is the 8th planet in the solar system, and it's the planet that has the most wind. There are really intense wind in the atmosphere of Neptune. Neptune and Uranus, they're giant planet, but they're ice giant planet because they're really farther out in the solar system. And the farther away you are from the sun, the cooler it is. So there will be ice, just not necessarily water ice, just different types of element that will be icy. And of course, maybe you thought of Pluto. I just did right at this moment. Pluto is still there. I mean, it has not disappeared. That's not still there. But now we call it a dwarf planet. And there are actually 5 dwarf planets in our solar system. Actually, in the solar system, there are planets, there's a star, there are dwarf planets and comets and asteroids. There are lots of things in our solar system other than planets. So actually, this is something like this, like the solar system. You see the sun and you see all of the planets, and then you have comets and you have asteroids. There are lots of things in our solar system. So when you look up, you see stars. I don't know where you live, but maybe you can see a few stars. I live in a big city, so because of light pollution, it's really hard to see lots of stars. But if I'm lucky and I get to go in a more rural area, somewhere where I can see the night sky, then I can see, maybe you can see 2,000 stars just with your eyes, just with the naked eyes. That's a lot of stars. Do you think that those stars also have planets? Maybe if you are listening with a class, maybe you can tell your teacher if you think that most stars, like if I pick any star in the night sky, do you think that there's a planet around that star? Or do you think that maybe there's only planet around few stars, like the sun?
Let me ask for a second. So Miss Foster's class, what do you guys think? There's a lot of planets, no planets?
What?
Answer the question. No, not that.
Yeah.
Yeah,
it's cool. You can see them everywhere. It just depends where you are. But
Okay.
and we're in more rural areas, so we can tend to see them probably a little bit better than you, since we don't have light. But,
So
yeah.
you see a lot of stars, but do you think that around those stars there are planets? Or there are no planets.
I mean, in certain, yes,
For
I
some?
think more.
for some, and there's a lot of it we haven't discovered. So I mean, there could be and there couldn't be. We just have to keep running tests.
Keep exploring, keep running tests. But hey, I think that's a perfect answer, Frédérique. So take us away. Tell us more.
That's a very good answer. Actually, this is what I wanted to talk to you about mostly, like how to find those exoplanets. So the first exoplanet was discovered in 1995. So that's not too long ago, especially when we think about astronomical discoveries. If we think about other kinds of objects that are in the sky, maybe we know we know them for thousands of years, 100 years. But here it's like that's the first exoplanet was discovered not too long ago, only in 1995. So if you think back, we are in 1990, how many planets do we know? Well, we know 9 because of Pluto. But now, how many planets, including exoplanet, do we know? Well, we actually know a lot. We actually know over 4,000 exoplanets. That is a lot of exoplanets. That is a lot of planets. All 8 planets in our solar system and over 4,000 exoplanets that we know of at the moment. And as it was said just before, this is only the planet that we've discovered so far. In fact, we think that all stars have 1 or more planets. We now think that planets, they're quite common. So if I were to pick a star at random in the sky, and you were to ask me, Frédérique, is there a planet there? I would say yes, because they all have some. So it's really exciting to see. It's a really new field too. So if you have to remember something of this presentation, it's not that number. No, remember that there are a lot of exoplanets, like over 4,000 exoplanets. I think since the first day that we've discovered one, it's something like we're discovering a new planet every 3 days. So in 1 week, in 1 month, in 1 year, we'll always know more and more exciting exoplanets. They're really different too. They have different sizes. Some are bigger than more massive than Jupiter. Some are really small. But still, it's really exciting to see all of the different kind of planets that we're discovering. So this is the first exoplanet that was ever discovered. This is 51 Pegasi b. And this is its star, 51 Pegasi. So 51 Pegasi b was discovered in 1995, and it was quite a surprising discovery. The method that we use to discover the planet doesn't enable us to actually see it. So what I'm showing you here, it's an artistic rendition. So it's a picture. It's really like a drawing, not a picture, not really an image of the system. It's really a drawing. All what we knew of the planet at that time was that the planet was about the same mass as Jupiter, and we knew that the star 51 Pegasi looked a lot like the sun. So the sun, you saw a picture at the beginning, a real picture of the sun. So here, the star is being drawn like the star, like the sun, and the planet here, as the only thing that we know, it's that the planet looks like Jupiter. Well, it's being drawn with bands, because Jupiter, you've seen it earlier, it has like lovely bands. But we don't know that. We only know that the planet is about the same mass as Jupiter. What's really interesting about this system, it's, if you think about the solar system, you have 4 small rocky planets, and then you have the 4 big gas giant planets. But this planet, it's as big as Jupiter, but it's on a really short orbits, which means that it takes 4 days for 51 Pegasi b to go around its host star. 4 days, that's really short. I mean, it takes the Earth 365 days to go around the sun. This planet goes around its star that is as big as the sun in only 4 days. So it's really, really, really close to its star. As this type of planet has no equivalent in our solar system, we gave it a new name. And those Jupiter-like planets that are really close to their host star, we call them hot Jupiter, because they look like Jupiter and they're really hot. So that's a good name. I like it. And when we name a planet, we just take the name of the star. So here, the name of the star is 51 Pegasi, and we just gave it a letter. So the first planet that we discover around the star, we'll call it name of the star, small b, and then the second one will be small c, and then the third one will be small d. This is how we name planets. Otherwise, it would be way too complicated to give them names like the moons around Jupiter that are like of the names of like Greek gods. So it's better that way. Okay, so the image I just showed you, it was a drawing. It was an artistic rendition. It's actually really hard to see a planet. Let me give you an example. So here we are in the rings of Saturn, and do you see a small white dot like in the middle? Like here. Do you see it, the small white dot?
I sure do. I like really squint
It's
there.
really small. Well, that's the Earth. That's the Earth as seen from Saturn. So Saturn is really close. It's in our solar system. It's a planet that's not too far away. But still, when you are at Saturn distance and you look up towards the Earth is already really small. So it's really hard to see planets that are orbiting other stars, because the stars are so far away. They're not just far away, they're also very bright. I'm sure you've all done that at some point. You're walking outside with a friend maybe, and it's really sunny, and then you want to look at your friend, but you kind of cannot see the friend because it's too sunny. So you just put your hand like to block the sun, then you see it better. You see your friend better. So it's a bit the same thing that we want to do when we want to take a picture of an exoplanet. So here you have an image of HR 8799. This is a star, a really bright star. But now I want to be able to look and to see better, and I want to be able to hide the star. Because here there are actually 4 planets that we can see. Okay, I will give you 10 seconds. Try to see if you can detect those 4 giant planets around HR 8799.
Dun, 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 dun. I can't. I have no idea. I'm stumped. I'm stumped. I think our classes are too. We got a lot of hands going up in the air and behind the scenes.
It's really hard, right? Okay, I will tell you what we do. The problem that we have here is that the star is really, really too bright. So what we will do is that we will hide the star, like by placing a mask. The same thing that I do when I'm walking outside and there are lots of sun and I want to see something better. I will hide the sun with my hand. But now I will use what we call a coronagraph. So a coronagraph, it's a mask that we put on the instrument, and then we will hide the star. We will hide the middle of the star. And then this is what we see. Here, you should be able to see now 4 planets. So I have one here, another one here, third one here, and the last one there. Those are the 4 planets around HR 8799. This system with 4 planets was directly imaged in 2008, and since then it's been studied without ends. So here you can see images between 2008 and 2016 of the 4 planets. What are they doing, the 4 planets? They're doing something really, really special. They are orbiting the star. They are going around the star. It means that they are gravitationally bound to the star, and that's really great. Actually, to me, this is the prettiest picture of astronomy. Of all the pictures that you have seen or will see, this is awesome, because here what you see that planets, they're not just something that we have found in our math equation. You see that they're real. They're going around the star, and that's a really, really great picture. Thing is, we know of over 4,000 exoplanets, and we've been able to take a picture of about only 20. So it's really, really hard to take a picture of an exoplanet because they're really, really faint in comparison to the whole star. That's really, really bright. And I think that's it for me. I see a lot of questions, so I think I will go into the questions if that's all right.
No, you have to keep talking for 30 more minutes. No,
I can do that.
I bet you can. That was amazing, Frédérique. What a cool presentation. Thank you so much.
Thank you.
So yeah, let's dive in with questions. We've got groups on YouTube from all over the place. We got a bunch of groups live that joined us after we got underway. This is a really super diverse session today. So we've got classes in Nevada, California, Alabama, Texas, Washington, Wisconsin, and Wyoming. So we've got 3 of the 4 W states as well, which is the first time in the history of this broadcast that's been the case. So way to go for all you guys. Let's start with Ms. Booth's class. I know they need to go soon in Las Vegas. So Ms. Booth, come on in and you can share those questions you typed in, but live instead. So just demute your microphone. And in fact, all our teachers can demute their microphone. So get that ready. That's totally fine. And Ms. Booth, I'll let you know when you're good to go. Hi, we can't hear you. So just microphone symbol on the bottom of your screen and you'll be set. There you go.
You guys
Perfect.
hear me now?
Yes.
Sorry, I have so many screens going on and so many windows. But hi, everyone. Hi, Frédérique. I appreciate all of the team. I appreciate what you guys are doing. for our students. It's really cool. So I have a few questions. I am a math teacher, so a lot of them are related to math, and I'll just go right into it. Is math really such a significant subject? What type of math do you use in this field? How often do you use math in your career? And the last one, what has been your experience as a woman in STEM?
So such nice questions. Okay, so I will start with math in general. Math is the language of the universe. So you need to be able to talk math to be able to understand the universe. Math, and I will also say computer programmation. That's also really important. So I would say that math is something that I use most days, even if it's just like easier math, like just algebra. That's something that I would do every day. And then we also do lots of calculus. That's really important, and everything with oh, that's hard because I know my math in French. But everything with log equation, that's also really important. When we think about the brightness of stars, we use a log scale to be able to talk about the brightness of stars. So math is really, really important. So I would say it's really significant. I remember being in high school and learning trigonometry and wondering if I would use this. Like, and yes, I would say that in astronomy you use trigonometry most days. You use math pretty much every day. So math is it's really important. Yeah. And I think the last question was what was my experience as a woman in STEM.
Yeah.
Yes. Yeah. So I to get my degree, so I have a PhD in astronomy. I first studied physics as an undergrad, as undergraduate studies. So physics it's also something that where we use a lot of maths, but it's also a field that is mostly where we have mostly men, not a lot of women. I would say, I think in Canada it is pretty much the same in the US. It's about 20% of women against 80% of men. So it can be a bit harder. I wasn't used to be in a classroom with that many men before, but I feel that there are some challenges, but I think it's getting better. I think one thing that can make it better is if you have a math teacher that's a female. That I think that's really great too. I didn't have a physics teacher that was a woman until my last class during my PhD. So not during high school. I'm in Quebec, so we have Cégep, that is like in between high school and university, and then between Cégep, not in Cégep, not during my undergrad, not during my master's. It was only in my last class of like the I studied a lot. So the last class of all the classes that I took is the only time that I had a woman professor in physics. But I think it's changing. It's changing slowly.
Well, that's a positive tack, and thank you for answering all those questions. Your kids are set now. They've got all the math information for this. That's awesome. Let's go to Miss Foster's class, joining us in Tuscaloosa, Alabama. If you guys have a question, go for it. Go for it.
Can I ask my question in French?
Yeah.
Elle a pris combien de temps à devenir astrophysicien?
So how much time did it took me to become an astrophysicist? En français, pour une femme, on va dire astrophysicienne, but it's really just a small thing. So it's actually a lot of years of study. So as I said, it's a bit different in Quebec, but I will try to use the system that's mostly used in the US and the rest of Canada. But you will have like 6 years of high school, if I'm not mistaken, and up to grade 12, and then you go into university and you will have 4 years of physics, and then you are a physicist. So if you want to specialize into a field of physics, you can study different things. So you can study astrophysics. You can also study condensed matter. There are really lots of fields that you can go forward. So I chose astrophysics. And then I did a master's degree. That's 2 years. And then my PhD lasted 4 years. So I won't add it up, but it's a lot of years. But
So
yeah,
Frédérique is actually 50 years old. You just can't tell. No, it does take a very long time to become a doctorate, regardless of the field you're in, but you get the chance to do jobs that are really, really exciting and fulfilling. So it's something that in middle school and junior school, it's like forbidding this idea of so much school. But realistically, when you're done, a lot of my colleagues that are my age, 28, are already doctors. And so by the time you're 28, you're set for the next 40 plus years of your life doing something that is really exciting. So just keep that in mind if it's kind of scary. And by the way, Miss Foster's class, question in French, you guys never cease to surprise me. I love it. Frédérique, a note for you too. If you wanted to get rid of screen share, I don't know if you're seeing us right now, but you can kill your screen share so you can see us a little bit better.
it's okay. I'm seeing you. Everything is fine.
Okay. Awesome. Let's go to Ms. Becker's class, joining us in lovely San Diego. So Ms. Becker, come on in and take us away.
Hi, good morning. Thank you so much for allowing this to happen. This has been a wonderful, wonderful experience. I thank you on behalf of my students. Students always hear a lot about black holes, and one of the questions is, are black holes related to exoplanets?
Okay, that's a good question. Black holes are also really exciting, and they're not the same kind of object though. So a planet, it will form as a leftover from the star formation. So when you have a star that's like a baby star that's forming, it will form in a cloud of dust that will make up the star, and around it, there will be like some baby planets forming that will make up bigger planets. So this is how you form a planet. So a planet is really leftover from the star. A black hole, one of the way to form a black hole, if you have a really, really big star, really massive stars, those stars are really bright and they will live a really short life. And when they die, they will explode, and what will be left over from the life of the star can be a black hole. So they're really different objects, but we also see a lot of black holes. There is one at the center of our galaxy, and we think that there is one at the center of most galaxies. So they are also really exciting objects.
Fantastic. Thank you so much. All right, we're going to go to Miss O'Toole's class, joining us in Burlington, Washington State. Miss O'Toole's been the most enthusiastic, behind-the-scenes, excited face person of all time. So I'm excited for your question. I bet if it lives up to your enthusiasm, it's going to be a good time.
Thank you so much. Can you hear us?
Yeah, you're good to go.
That's great. Well, we are all here on Zoom. You can't see all of us, but we're like 40 people over here. And we have a lot of questions about the size of planets and the planets that you found so far, and any that are similar to Earth. So biggest and smallest. We're really excited over here.
That's a really good question. The first planets that we found were about the same size as Jupiter. And it's still a type of planet that's really easy to find, because the bigger they are, the easier it is to find them. It's also the closer in they are to their star, the easier it is to find them. This is why the hot Jupiter, so the planet that look like Jupiter, but that's really, really close to the star, this is why it was the first planet that was ever discovered, because it's really easy to find them. So at the moment, it's not about what the smallest planet that exists. It's mostly about what's the smallest planet that we can detect with our telescope, because the smallest, the hardest. And at the moment, we can find planets that are about the same size as the Earth, which means, think about the planet in the solar system. Okay, you picture them. Yeah, I see them. I hope you do too. So Jupiter is the biggest one, and then Saturn is a bit smaller, and then Uranus is a bit smaller, and Neptune is the smallest one of the giant planets. But now think of the rocky planets. You have the 4 rocky, Mercury, and then Venus, and then the Earth, and then Mars. The biggest one of those 4 rocky planets, that's the Earth. So at the moment, we can find planets that are about the size of the Earth, or Venus. Venus is about the same size as the Earth. But we cannot find planets that are as big as Mercury, for example, because Mercury is really small. It's just a little bit bigger than the moon, Mercury.
Very cool. What a thorough answer. Thanks, Frédérique. All right, we're going to go to Austin, Texas for Mr. Herber's class. So long since I've had a Texas class in. You guys always are super enthusiastic. So come on in, just demute your mic, and you're good to go. Hi there. We actually can't hear you right now for whatever reason, but hi, waving, I like it in the background. Your mic is demuted, so this should work. And if it's not, I really apologize for that. You can muck with it, try and smack it, but do type your question in the chat bar just in case. I'll come to you guys in a minute and hopefully we can get it working. But no matter what, if you type it in the chat bar, I'll relay it on behalf of your class. Sorry that there's a tech issue. We didn't get a chance to check that out ahead of time. So in lieu of that, I'm going to go to Joe joining us in Mount Orab, Wisconsin. Joe is our most enthusiastic individual student in the United States. So Joe, come on in and go for it.
Hi. I was wondering, what's your favorite exoplanet?
Ooh, no pressure.
That's a good question. I really like an exoplanet. I don't have a picture here, but it's JG204b. That's its name. I know, exoplanets' names are a bit boring. But I really like this one because it's as big as Jupiter. So I really like Jupiter-like planets. But its color will be different. We can't actually see it. It's another planet that we cannot see. But we think that if we could see it, the planet would be pink. So that's why it's my favorite one.
Awesome question, guys. All right, to Mr. Herb's class, please do use the chat bar. I just typed something in there, so you should be able to see where that is and share it. I'll come back in a little bit. Hopefully we get the mic working. We will have time for another round of questions for our live classes, so get ready, everyone. I just want to share a couple from YouTube first. So, Mr. Freeze's class, joining us in Green River, Wyoming. Welcome in for the first time. Nice to have you guys here. Let's see, you've asked a bunch of questions. So let's ask this one. How do you recognize patterns when searching for exoplanets to realize there indeed is a planet orbiting these stars?
Well, that's a really good question. So there are a few ways that we have to discover a planet. One of those ways, it's called the transit method. So the transit method, what we do is that we have telescope that will look at the sky without ever blinking. They just look at stars, at the same star for a long time without ever blinking. And if there is a planet, what will happen is that when a planet will pass in front of the star, this is the star, this is the planet. So when the planet passes in front, what we will see, because we're looking at the star, looking at how bright it is without ever blinking, we will see a small dip in the luminosity from the planet, from the star. And if we see that dip, and if that dip is repeating every, let's say, 12 days, then we know that there's something every 12 days passing in front of the star. And this is how we can find planets. And this actually requires a lot of maths. So when you do exoplanets with the transit method, you use this math all the time.
Yeah. Very cool. Thanks again for such a thorough answer. This is awesome, guys. For all our classes, seriously, you're in for a treat. If this is your first time joining us, most of our, all our sessions are good. This is a really, really fun program today. Miss Foster's class, come on back in. You have to ask the question in a third language. It can be Spanish or Chinese or whatever. Yeah, no pressure.
What's up, Jesse? All right, so we have a virtual student. He wants to know, well, we all want to know, what technology is used or will be used in the future to detect the compositions of exoplanet atmospheres?
Cool.
Ooh, that's a really good question. Especially when you think about life, because to be able to find life that's not like something that we can talk, like maybe like some life from bacterium, we need to be able to study the atmosphere of exoplanets from at a distance, because we cannot go on exoplanets. They're just too far away. So one instrument that will be used in the near future is called the James Webb. This is the James Webb Space Telescope, built by NASA, and it has also one instrument that is Canadian. And that instrument is called NIRISS, and it will it has been specifically built to look at the atmospheres of at the atmosphere of exoplanets, to be able to detect something maybe like water on the atmosphere of exoplanets, and that will be the next step in finding life. So now we can find planets that are about the size of the Earth, at about the same distance that the Earth has relative to the Sun. We will call them Earth-like planets, and the next step will be to see if there's water in the atmosphere, and that's something that James Webb will be able to do with the NIRISS instrument.
Yeah, fantastic.
Really great question.
It is a great question. Thanks again, Ms. Foster's class, for your two. And a note, Frédérique's done this before in the past, and I don't want to volunteer for you today, but you usually answer questions after the fact too. So if classes can't get all their questions in today, share them with me. I'll pass them to Frédérique, and we can get them all answered, because I know you guys are super keen.
Sure.
Two quick notes in the bottom of the screen. James Webb Space Telescope, if you didn't check that, check it out. And Frédérique's colleague, Natalie Ouellette, has done a whole bunch of programs with us. Check out her sessions on our YouTube page. She is the James Webb sort of outreach specialist in Canada. Some really, really cool follow-up sessions. All right, Ms. Becker's class. Let's whip through these guys. Mr. Herb, do type in those questions. I think you might have done so. Awesome. So Ms. Becker, come on up.
Another question that we have would be, how do you celebrate? What do you do when an exoplanet is discovered, or you find something new? Is it a what do you do to celebrate?
Champagne for all.
That's a good question. I guess it depends on the type of exoplanets too. Because if you think about the transit method, so the one where we find exoplanet when it passes in front of a star, we know of a lot of planets by this method. So maybe you're happy, maybe you don't celebrate as much as you used to, but I mean, it's a really nice discovery. When you get to image a planet, that's really awesome. That's really rare, but it's something that we do celebrate in between ourselves. I think even when someone just publishes a paper, so just a scientific article about their findings, can be a discovery of an exoplanet. It can also be studying an exoplanet. We always make sure to celebrate it in our research group. That's for sure. It's a big accomplishment.
Yeah, what a cool question. We haven't got that one in a very, very long time. You want to see scientists at their peak excited? Watch when they land a rover on Mars. There's videos of this on YouTube. It'll blow your mind. It's the best. So Mr. Herb's class, I'm going to bring you guys in. In the off chance your audio is working, you can say it, but I'll just wave and say hi and share your two questions with Frédérique. So welcome in, guys. So their questions are, which stars have the most exoplanets? Is there a star that we've discovered that has more than others? And have you personally found or discovered exoplanets yourself?
Okay, so the star with the most planet, that's actually the Sun with its 8 planets. We also know of a few stars with seven planets, but we don't know of any system with more than 8 planets at the moment. And the second question was, did I find any exoplanet myself? No. Yeah. I'm a researcher, just not a finder.
Okay. Fantastic. Great answers. By the way, if we do discover an exoplanet with 8 or an exostar with 8 planets, you can bet that Pluto will instantly be remade a planet so we can have the most. I guarantee that happens. All right, Ms. O'Toole, let's go back to Washington. We'll take 2 more questions from you. Joe, you're coming up next, and then we'll take one great one from YouTube to end us off. So Ms. O'Toole, come on in.
I'm so excited you called on us again. We just got a great question from Joshua. He's wondering, if you did find life in space, what would you do?
Ooh.
That's a great question. It's a bit something that's kind of happening right now. A month ago, there was a team of researchers that announced that they had found a really special chemical component in the atmosphere of Venus. And that element, it's called phosphine. Phosphine on Earth, we will mostly know it because it lives in the stomach of some animals, some mammals. So why would there be phosphine on Venus? That was a big question. And then it went everywhere in the media. What's happening? But sadly, yesterday was actually proven wrong by another team of scientists. So we're not sure what's happening on Venus. Is there phosphine? If there is no phosphine, if there is phosphine, maybe it would be really exciting. Maybe it could be life. Maybe it's not. So that's a really big question. But let's say that we find life somewhere. But we do. We will need multiple teams to study the data to be sure that there's something. And I believe that the life that we will find, because I do believe that we will find life sometime, I will say soon-ish. Well, in my lifetime. I do believe that we will find life in my lifetime. But I believe that this life will be really small, and this is not the kind of life that we will be able to communicate with. So we will need to study it a lot from a distance. but we won't be able to get there, and we won't be able to talk to it. So that will be hard.
I love this question. We get it in every single one of our space broadcasts. And simply put, I mean, and you can offer your thoughts as well. It would be the biggest scientific discovery ever. It would be another biosphere on another world, something that could have potentially seeded life on Earth, something to have evolved completely separately. I mean, it would be just an incredible thing, whether it's something like a bacterium or a cool lizard that walks up and licks the camera on Europa. I mean, that would be really cool. No, you don't need multiple teams of scientists to confirm that. But that, you know, it's really exciting. And the amount of effort that's being done by scientists all around the world, both in seeking chemicals on other worlds, in looking for actual tangible signs of life, and looking for water, and figuring out, you know, space missions to Europa, Titan, and more. It's the coolest time to ever be involved in space research ever in human history. So for the classes and our students here today, there's so many opportunities for you guys in the coming years. You have no idea. And I'm looking forward to having more sessions like this in the next few years so we can highlight some of that exciting new research. With that, 2 more questions. Joe, come on back in. Take us away. I know you have questions.
Yeah, I do. So, what colors do exoplanets come in?
Ooh.
That's a good question. So, exoplanets, as I said, mostly we cannot see them. And when we can see them, you saw the 4 exoplanets around HR 799. They're really small, and they're mostly whitish. We cannot really see the colors. But when we look at what we know about the planets, and when we look at their the different physical characteristic that they have, then we can have an idea of the color. We don't know for sure because we cannot see them. But we think that there will be, like in our solar system, there are various colors. We have lots of orange, like Jupiter, and then some blues. Blues comes from a molecule that is called methane that makes a little tinge of blue in the atmosphere of Uranus and Neptune. Then you can have red-orange, like Mars, and there could be some pink. It really depends on what's the composition of the atmosphere of the planet, and this is what we will see. But we think that there are a lot of variety in sizes and in colors.
So one of the things that I love in dinosaur and space presentations. So in dinosaur presentations, this idea is like, what did life used to look like? And you can think of all the diversity of life on Earth today, and the same amount of wild and amazing creatures existed back then. We know so few dinosaurs compared to the amount of species on Earth today that world is just opening up to us. And same with planetary exploration. Look at the planets in our solar system. Look at the moons in our solar system. And a really great way to do this, NASA has a travel poster series envisioning the future of space exploration called Visions of the Future. So check that out. Super, super cool. All the incredible things in our solar system. We've got 50,000-foot ice cliffs. We've got canyons that dwarf the Grand Canyon. We've got geysers that shoot 100 miles into the atmosphere. Incredible stuff. And that's the sort of thing that we're going to get better at exploring and learning about in other planets and other solar systems. So really exciting time. All the colors, Joe. All the colors out there. I love this question to wrap up. It's on YouTube. Madeline's been homeschooling over the last little bit, and you stumped her. You're such a good presentation, Frédérique. She wanted to be a biologist, but your presentation's got her waffling. What advice would you give to young astronomers?
That's a good question. So when I was younger, I actually wanted to be a geologist because I really like rocks. So I was always picking up rocks, putting them in my pocket, bringing them home. I would have rocks like everywhere. But then I got into physics a bit more, and I think physics is really interesting. It's really a science that explains the smallest, so what's inside an atom, to the biggest structure in the universe, like how do galaxies will interact. So this is how I got into physics, and then into astronomy. But if you like astronomy now, I don't know how old you are, but there are various things that you can do. First things, if you really like looking at the night sky, I think it's great to learn about the constellation. And even tonight, you can see Mars with the naked eye. Actually, maybe I can share again this here.
While you're pulling that up tonight, yeah, Mars has been incredible. For all the classes, if you guys haven't gone out and seen Mars lately, it's the most incredible I've ever seen it in my entire life. It's so cool. So there you go.
So, and tonight it will be easy to find. It depends where you are. So this is for where I live on Earth. It might be a bit different depending on where you are, but you should look it up. Tonight, for me, it will be close to the moon. So Mars when you look at the night sky, Mars would be really, really bright because it's a planet and it's close. And also, if you look at the planet and a star, if you look at the planet closely, you look at it for a while, you see it won't twinkle. But if you look at the star for a while, you will see that the star is twinkling. Yeah. So if you want to make sure that you're really seeing a planet and not a star, then look at it for a few seconds. Mars will appear slightly red, like I said, whitish red, and that this is something that you could start with. So I think if you're interested in astronomy, I would say try to learn about the night sky, see Mars. I really like to look at Jupiter, even just with binoculars, because when you look at Jupiter with binoculars or just a small telescope, you can see the moons. Jupiter has 79 moons, but with binoculars or small telescope, you can see 4. And to me, that's the best thing that you can see in a small telescope or binocular. So I would look that way first, and then I'm sure you will find lots of things to discover in the night sky.
Yeah. Fantastic. Well, hopefully all our students go and do that. My favorite, by the way, if any of you have never seen Saturn's rings through a telescope, it is one of the coolest things ever. It just looks like a dot with a line through it, but it will blow your mind. It's unbelievable. Frédérique, what a fantastic and super fun session today. So thank you so much. For all our students, check out the Exoplanets U Montreal website to learn more about exoplanets, all the cool work they're doing there. And then do send me your questions, either Jesse at exploringbytheseat.com or ebtsoyp@gmail.com. You have those emails somewhere, so you're good to go. What we do is we'll do at the end of every session, I'm going to bring in all our live groups. If you guys could join me in saying a big thank you to Frédérique today. Go for it, guys.
Thank you.